Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Yeah, I think we stopped with this in the last class. And I also said I'll share some proof with you on WhatsApp, but I did not. So let's do that now. Let's do that now. I don't think I showed you this slide. Okay, let's see this one now. So in this figure, we are given that AB is parallel to CD. We are given that AB is parallel to CD. And we are also given that O is the midpoint of AD. That means OA is equal to OD. O is not given to be the midpoint of BC. O is not given to be the midpoint of BC. So we cannot say that OB is equal to OC. No, O is only the midpoint of AD. So OA is equal to OD. That's all. So AB is parallel to CD is given. O is the midpoint of AD is also given. That means OA is equal to OD. We have to prove that these two triangles are congruent to each other. And also, once you prove that the triangles are congruent, you should also show that O is the midpoint of BC. You must show that O is the midpoint of BC. That means you must prove that OB is equal to OC. So once you prove that the triangles are congruent, OB is a side of this triangle. OC is a side of this triangle. When you prove that these two triangles are congruent, their corresponding sides will be equal and their corresponding angles also will be equal. So probably these will be the corresponding sides. So since the triangles are congruent to each other, you will then say that corresponding sides of congruent triangles are equal, or corresponding parts. Parts meaning sides or angles. Corresponding parts of congruent triangles. What are the parts of a triangle? Sides and angles. So the corresponding sides of the congruent triangles will also be congruent, will also be equal. So once you show that this triangle is congruent to this triangle, this side is equal to this side will happen through CPCT. Corresponding parts of congruent triangles are equal. All right. So we have all the information to prove that these two triangles are congruent. Okay, so last class we discussed them. We'll see them again. So one is vertically opposite angles are equal. Angle 1 is equal to angle 2. See here. In this is the first triangle. See here. AOB is the first triangle, and all this is about triangle AOB. All this. The other is the triangle COD. And the second information after the equal to sign is all about triangle COD. So angle 1, you can see I've marked it here. You can see it here. Angle 1 of triangle AOB is equal to angle 2 of triangle COD, vertically opposite angles. OA of the first triangle AOB is equal to OD of the second triangle, because it's given that O is the midpoint of AD. So this side of the first triangle is equal to this side of the second triangle, because it's given O is the midpoint. And then angle 3 of the first triangle, this is angle 3. I've marked it's not visible clearly, but I've marked 3 here. Angle 3 of the first triangle is equal to angle 4 of the second triangle. Alternate interior angles are equal, because we know that we are given that these two lines are parallel to each other. So angle 3 is equal to angle 4. Alternate interior angles are equal. Alternate interior angles are equal. So what rule this makes? For angle 1 and angle 3 of the first triangle, OA is the included side. OA is the included side in the first triangle. For angle 1 and angle 3, OA is the included side. See, the side is OA, and we have mentioned about angle O and angle A. The side is OA. We have mentioned about OA. We have mentioned about OA, and here you have angle 1 and here you have angle A. That is, you have angle 1 here and angle 3 here. So for angle 1 and angle 3, OA is the included side. Similarly, in the other triangle, we have mentioned about angle 2 and angle 4. In the second triangle, we have mentioned about angle 2 and angle 4. Angle 2 and angle 4. See, this is 2 and this is 4. And for angle 2 and angle 4, OD is the included side. OD is the included side. So clearly it is two angles and the included side. ASA. Two angles and the included side. See here, angle. See, angle, side, angle. See here, angle, side, angle. Two angles and the included side. Now, supposing we have written information about, supposing, we have written, say like this one, angle 1 is equal to angle. Okay, before that, let me ask you a question. Now, for angle, if I call this angle, this is already angle 2. Supposing I call this angle 6. Now, which is the included side for angle 2 and angle 6? Which is the included side for angle 2 and angle 6? Why is the class silent? Which is
OC, ma'am.
very good. OC, very good. OC or CO, very good. Okay. Now, Raja, again, which is the, now this is angle 4. Okay. Raja, which is the included side for angle 4 and angle 6?
Ma'am, sorry, ma'am, I was in the mute. CD or DC, ma'am?
CD or DC, very good, very good. And which is the included side for angle 2 and angle 4?
Ma'am, OD, ma'am.
OD, perfect. Now coming to this triangle, Raja. Okay, angle 1, angle this is 3, and let me call this angle 5. Now you tell me the question as well as the answer, Raja. Like you say for angle 2 and angle 4, OD is the included side. So like that, you tell me for this triangle OAB.
Ma'am, for angle 1 and 3, the included side is AD.
1 minute. For angle 1 and 3, the included side is
AD. Sorry, AO, ma'am.
OA. Yeah, OA or AO. Correct. Both are correct. Yeah, both are the same. Yeah, then.
For angle 3 and angle 5, the included side is AB, ma'am.
Very good.
For angle 5 and angle 1, the included side is BO or OB.
Very good. That's it. Yeah. So like this it is. So it's like this. So now in the two triangles, in these two triangles, we have mentioned about, see what you have written here. What have we written here? We have written about angle 1, we have written about angle 3 and OA. Clearly for angle 1 and angle 3, OA is the included side. Included side, two angles and the included side. So ASA, see the side is in the middle. It's included between the two angles. See, these are the two angles. The side is included between the two angles. So ASA rule. In the other triangle also, for angle 2 and angle 4. See, this is angle 2. This is angle 4. For 2 and 4, OD is the included side. See here, OD or DO. So clearly, by ASA congruence criterion, the two triangles are congruent to each other. It's very easy to name, when it is ASA. See here, you have mentioned about. Listen very carefully. It's very simple. Just listen carefully. Now, if you call this triangle, you call it like this only. You start from, the information which you have used in the proof. So we have mentioned about angle 1. So if you say, see, you have mentioned about angle 1 and angle 3, you start from there only. You name the triangle from there. You have mentioned about 1 and 3. So let's start from 1. Then we'll say 3. Now, so 1 is what? O. Then 3 is A. So which is the third angle? B. So one triangle is OAB. See, I've written something else here. This is also correct. What I'm writing here is also correct. Okay, so angle 1 is O, angle 3 is A, then the third vertex B. Now correspondingly, for angle 1, it is angle 2 in the second triangle. So again O, because it's O only in both the triangle. Angle 1 is O in the first triangle. Angle 2 is also O in the second triangle. O. Now then you wrote angle 3. Angle 3 goes with angle 4 because 3 is equal to 4. If you say 3 here, it's 4 here. So if you say A here, it is D here. D. Write the corresponding angles. See here. For 1, it is 2. For 1 in the first triangle, it is 2 in the second triangle. O. For A in the first triangle, it is D in the second triangle. Okay, so if it is A, it is D. Then the third vertex C. OAB congruent to ODC. If you say AOB, so you're saying this one AOB. If you say AOB, then you should say it's congruent to A goes with D. So D, goes with O. So O, and then the third vertex DOC. See, that's what I've written here. AOB, DOC. ASA rule. CPCTC. So we proved that the two triangles are congruent. Now we have to show that O is the midpoint of BC. So you can see here from the way we have named the triangles, you can see here OB is equal to OC. OB is equal, see here, the second and third letters. OB is equal to OC. CPCT. That is, now that the two triangles are congruent, their corresponding sides are equal. So OB corresponds to OC. So CPCT. If OB is equal to OC, if OB is equal to OC, it clearly means that O is the midpoint of BC. O is the midpoint of BC. So O is the midpoint of BC. Please write down, children. Now I'll tell you one more thing. Listen carefully. Now supposing you know that you can also write about these angles. Now supposing you don't mention the vertically opposite angles. Just a minute, children. Please write on this. I'll just get back. 1 minute. I'll just get back, children. Please write down this in your notebook. We have not written this, right? We only understood this in the last class. Am I right?
Yes, ma'am.
Yeah, please write down, children. I'll also give you the alternate proof. Please write. Yeah. So the alternate proof, children. Now supposing you mention about, this one, this angle. All right. So in the two, you will have to do it in the same way in triangle AOB and triangle COD. See here, angle 1 of the first triangle is equal to angle 2 of the second triangle. Alternate interior angles are equal because these two lines are parallel. These two lines are parallel line, transversal parallel line. Angle 1 is equal to angle 2. Alternate interior angles are equal. Similarly, parallel line, transversal parallel line. Alternate interior angles are equal. Angle 3 is equal to angle 4. So 1 is equal to 2, 3 is equal to 4. Alternate interior angles are equal because you can see that AB is parallel to CD. And then you also know that OA of the first triangle. See here, all this is of the first triangle. And all this is of the second triangle. This is of triangle AOB. And this one is of triangle COD. Angle 1 of this triangle is equal to angle 2 of this triangle, alternate angles. Same thing, 3 is equal to 4. Then OA of the first triangle is equal to OD of the second triangle. So what does this make? When you say angle 1 and angle 3, which is the included side? In the first triangle, when you have mentioned about angle 1 and angle 3, which is the included side? In the first triangle, we have mentioned about angle 1 and angle 3. Then which is the included side for angle 1 and angle 3? Yes, children, you know it. Why no response? What happened, children? Why nobody's answering? You don't know? Class, use the emoji. Raise your hand. Rishmika, Shri, Arjun, Netra, Madhumita, Raja, Dhanya, Tanishka, and Shri Jana. Are you there? Yeah, he's there. Now, children, what happened? Which is the included side for angle 1 and angle 3, children?
Side AB, ma'am.
AB. And what about for angle 2 and angle 4?
CD, ma'am.
CD. But have you mentioned about AB and CD? Have you mentioned about AB and CD? No, we have mentioned about OA and OD. So clearly, you have mentioned about two angles and not their included side. You have mentioned about angle 2 and angle 4. But if you say about 2 and 4, the included side is CD. No, but you have mentioned about OD. So here it is AAS, two angles on some other side. You cannot write SAA. No, you cannot write SAA. This order is important. Angle side. By AAS rule, the two triangles are congruent to each other is also fine. You can prove this using ASA or AAS. You can also mention this angle. You can use this vertically opposite angle also. You can mention, like, supposing you can say angle 5 is equal to 6, 3 is equal to 4, and then sorry, the 1 minute. You can also mention this. See here, angle 6 is equal to angle 5. Then angle 2 is equal to angle 1 is equal to angle 2, and then OA is equal to OD. OA is equal to OD. This also is AS. 6 is equal to 5. 1 is equal to 2. And OA is equal to OD is also AAS because it is two angles on some other side. Yeah, make a note of this, children. Maybe I'll write it neatly again. The other ways of proving. Okay, so you can, if you say angle 1 is equal to angle 2, vertically opposite angles are equal. Angle 5 is equal to angle 6, alternate angles are equal. OA is equal to OD. OA is equal to OD. This is AAS. And if you say angle 4 is equal to angle 3 is equal to 4. Sorry, not 4 is equal to. Yeah. If you say angle 3 is equal to angle 4, and then angle 5 is equal to angle 6, and OA is equal to OD, then also it is AAS. Yeah, please think about it and ask me if you don't understand. So here you have mentioned about angle 1 and 5, right? For 1 and 5, which is the included side, children? For 1 and 5, which is the included side? For an
OB, ma'am.
OB. But what have you mentioned about in the proof? OA. OA. In the other triangle, you have mentioned about 2 and 6, angle 2 and angle 6. So which is the side included between the angles 2 and 6?
OC, ma'am.
OC. OC. But you have mentioned about which side? OD. So it is 2 angles and some other side, not the included side. Same thing in the case, in this case. So here it is ASA because it is 2 angles and included side. For these 2 angles, this is the included side. For these 2 angles, this is the included side. So ASA. In these cases, you can also write this. You can write this one or this one. So you can write it in 3 different ways, this proof. You can do this proof in 3 different ways. All the 3 are correct, but the rule is different. Yes, children, please make a note. Done?
Yes, ma'am.
Yes, ma'am.
All right. Yeah. So here in quadrilateral AC, everybody, is it over? Should I wait for anyone? Okay. So in quadrilateral ACBD, ACBD, you can see here ACBD. AC is equal to AD. AC is equal to AD. And AB bisects angle A. AB, this line segment AB, it bisects angle A. This is angle A. This is angle A. Can you see that this AB is going through angle A? This line segment AB, it's going through angle A. So it's dividing angle A into 2 equal parts. That's why bisects. Which means this portion, angle 1, is equal to this portion, angle 2. That is angle CAB. Angle CAB is equal to angle DAB. DAB. CAB, this angle is equal to DAB, this angle. These 2 angles are equal because this is the full angle A. This is angle A. This AB, no, this line segment AB, it's dividing this full angle into 2 equal angles. So this angle is equal to this angle. See, if this line was not there, supposing the quadrilateral was like this. Okay, so this is A, this is C, this is B, and this is D. Now this is only one angle A. There's only one angle here. At A, there is only one angle. But what's happening? There is this line segment AB. Because of this line segment AB, this angle is divided into two angles. There is one angle here and here now. This angle is divided into two angles because of AB. And AB is given to bisect angle A. That means it divides angle A into two equal angles, angle 1 and angle 2, and they are equal. Angle 1 is equal to angle 2. With this information, you should show that these two triangles are congruent to each other. These two triangles, that is this triangle and this triangle, are congruent to each other. And then you have a question. What can you say about BC and BD? What can you say about BC and BD? BC is a side of this triangle. BD is a side of this triangle. Mostly, what can you say about those two sides? That they are equal. Because once the triangles are congruent, their corresponding sides will be equal. So mostly there will be corresponding sides. So what can you say about BC and BD? They are equal sides. Those two sides are equal. Those two sides are equal because you're going to show that these two triangles are congruent to each other. So once you show that they are congruent, what can you say about BC and BD? That they are equal because they are congruent. No, we'll have to prove that. Okay. Now tell me, children, what information do you know? It's just about listing the information. Tell me.
Ma'am, we know that AC is equal to AD.
Which are the triangles? Name the triangles.
Triangle ACB and triangle ADB, ma'am.
ACB on the top and ADB below. Okay, in these two triangles. Okay.
AC is equal to AD.
Let me just number the angles. Let me call this angle 1 and angle 2. Yeah. Yes, Madhumita. Yeah.
AC is equal to AD, ma'am.
AC is equal to AD because it's given. Correct.
Yes, ma'am.
Yeah.
And angle 1 is equal to angle 2, and that is also given, ma'am.
Okay. Angle 1 is equal to angle 2. Correct. Then
And also AB is equal to AB because it's common.
AB is equal to AB common side. AB is equal to AB common side. So what is the rule here? Do the sides AB and AC include angle 1? Do the sides?
Yes, ma'am.
You've mentioned angle 1. Which are the arms of angle 1? Angle 1. Which are the arms of
AC
angle
and
1?
AB, ma'am.
Yeah, AB and AC are the arms. And we have mentioned about AC and AB only. And for angle 2, which are the arms for angle 2? For angle
AD
2,
and AB, ma'am.
AB and AD. And that's what we have mentioned here, AB and AD. So clearly it is two sides and included angle. Two sides and the included angle. So what's the rule, Madhumita?
Ma'am, it's ASA congruence rule.
ASA means two.
No, ma'am, SAS congruence rule.
SAS congruence rule. That's all it is. So once they're congruent, BC is equal to BD because they're the corresponding sides. Write down, children. Please write down. Done, children?
No,
So you
ma'am,
can
just
see.
one minute.
Oh, sorry. Okay.
Completed, ma'am.
Yeah.
Completed.
Yeah.
Completed, ma'am.
Completed, ma'am.
Completed, ma'am.
Yeah, children. So what can you say about now? I hope you didn't have trouble in naming the triangle. So it's very simple. See, here what you can use is AB and AC you have, right? So AB is equal to AB. And then the other one is AC is equal to AD. AC is equal to AD. So just write this AB as BA and write this AB as BA. So like I told you, BA AC, BA AC. So BAC, BA AD, BAD is one of the ways. You can say BAC, BAD. BAC is equal to, I'm sorry, congruent to BAD. If I'm not clear, I'll just repeat. See, I said just write out what you have written. AB is equal to AC, and then AC is equal to AD. AC is equal to AD. Now A is common, right? A is common. So make this one BA, AB as BA. They make this AB BA. Now it's like BA AC, BAC, BAAC. Oh, sorry, I went wrong. AC is equal to AD. Sorry, AC is equal to AD. BAAD, BAD. Okay. So, yeah, once you, write the triangle, the congruent, from this order, you can make out that BC is equal to BD. BC is equal to BD. So what can you say about BC and BD? They are equal. Have you understood how to name the triangle, children? That's very important.
Yes, ma'am.
Yes.
Yeah, see, you can do it like this also. If you say DAB, go in the same order. See, you're saying DAB, right? So what goes with DA here? CA. So CAB. CAB. Okay, I think you'll get used to it. That's the next one. So I want one of you to explain this. I'll show you the answer. Go through this and I'll ask one of you to explain. Yeah. It's a very simple proof. I have also, separated the triangles from the main figure. You can see it there. Yeah, please understand clearly and be ready to explain. Maybe you can go through the proof first and then write down on whatever. Give you 5 minutes for that. Was that enough time, children?
Completed, ma'am.
Okay.
Two minutes, ma'am.
All right. Done, children?
Yes, ma'am. Completed writing.
Yeah. So you can see here ABCD. I'm not explaining the proof. We'll just see what's given. ABCD is a quadrilateral. Yeah, ABCD is a quadrilateral. All right. In which AD is equal to BC. And angle DAB is this full angle. See here, DAB, this full angle DAB is equal to CBA. So this full angle, these two angles are equal. This angle is equal to this angle. We need to prove that given this side is equal to this side and this angle is equal to this angle. Given these two information, we need to prove that ABD is congruent to BAC. So which is ABD? See, I've taken it out separately from the figure. This is the ABD. This is ABD. I've removed it from the figure here. ABD. See, this is ABD, right? This one. I've taken it out separately here. ABD. And then BAC. BAC is this piece. This one is BAC. This one is BAC. I've taken it out here. BAC. So you can see the two triangles separately here. You need to show that these two triangles are congruent to each other. All right. Okay. Now see here, you know that this angle is equal to this angle. You can very well make out that this angle is a part of the triangle BAD. See here, triangle BAD. This is the full angle. Okay, 1 minute. Don't see this line. This is triangle ABD. This is triangle ABD. This is triangle ABD. This line is not there. So this complete angle. So that's what you see here. And the other triangle is BAC, this one. See a BAC, this triangle. Don't ignore this line segment. Ignore this. So you can see the full angle here, this full angle. That's what is here, ABC, and with the full angle here. And then AD is here of this triangle, BC is of this triangle. It's given to us that angle 1 is equal to angle 2. This is what is angle 1 is equal to angle 2. See, this is angle 1, this is angle 2. Angle 1 is equal to angle 2 is given to us. So that becomes one information. And then AD is equal to BC is also given. AD is equal to BC is also given. Now the third thing is, I think I've explained it myself. The third thing is that these two triangles have some side in common. You can see from the name of the triangle. ABC. Which are the sides of this triangle? From the way it's named, which are the sides of this triangle? AB, BD, AD. Here, AB, BC, AC. So AB is a common side. See here, which are the three sides of this triangle? AB, BD, AD. For this triangle, AB, BC, AC. So you can see that AB is repeated in both the triangles. Here also you have side AB and here AB. So this side AB is a common side. The side AB is a common side. See here, ABD, ABC. So this AB happens to be the common side. So AB is equal to AB common side. AB is equal to AB common side. So you have mentioned about this side AB. this side and this angle. In the other triangle, you have mentioned about AB, the common side, this equal side, and then angle 2. Clearly, it is SAS. Two sides and included angle. Because for angle 1, these are the two arms. And for angle 2, these are the two arms. So clearly, it is SAS, two sides and included angle. SAS rule, the two triangles are congruent. How do you name it? How do you name the two triangles? You can take up AD is equal to BC. AD is equal to BC, and then AB is equal to AB. AB is equal to AB. Take up this. And what is common? What is common? A. So write this AD as DA. In the rough column. In the rough column. Okay, A is common. DA, AB. Here what is common? B is common. So write this as CB and write this as BA. Children, do this in the rough work. You don't have to change the proof here. Let me tell you again. You don't have to change the proof here in the rough column. In the rough column, this is just for you. So write out the two things you've written. AD is equal to BC. Write that. Then write the other one. AB is equal to AB. AB is equal to AB. Write this. Now, what is common here? A. So write this as DA. So DA, AB, DAB is congruent to. Here, what is common? B. So you write this as CB and write this as BA, BA, CB, BA, CB, BA. So CBA, CB, BA, CBA, CBA. This is one of the ways of writing. This is one of the ways of writing. Okay, what I have written here is what is given here. Sometimes we don't take effort at all to name the triangles correctly. Whatever is given here, we'll just write it out. I have written the same thing, but I'm telling you how you can name it. Whatever is here, I've written here, that's all. And the rule is SAS. But how can you name it in a different way? See here, DAB, CBA is also correct. See here, DAB, DAB. That is the third vertex, first vertex, and then the second vertex, DAB. Correspondingly, it will be CBA. Please check. Please check here. DAB, see here, DAB. Then it will be CBA. The two triangles are congruent by SAS rule. So CPCTC, you will get these two results. CPCTC, you will get these two results. CPCTC meaning corresponding parts of congruent triangles are congruent, are equal. So BD is equal to AC. So you can see here BD is equal to AC. CPCT. BD is equal to AC. BD of this triangle is equal to AC of this triangle. BD of the first triangle is equal to AC of the second triangle, CPCT. Then angle ABD. Angle ABD is equal to angle BAC, which is ABD, this one is equal to BAC, this one. Okay, so you can, from this name, you can make out where is angle ABD, angle ABD is equal to angle BAC. Now, if it is angle, supposing it is angle DBA, if they say angle DBA is equal to angle, if you say DBA, it will be CAB, angle CAB. These two angles will be equal. See, I'm picking everything from the name, If supposing it is angle BAD, angle BAD will be equal to angle. If you say BA and D, second, first, and third. Here also second, first, and third. ABC, like this. Now tell me, for this order, if I say angle DAB, it will be equal to which angle? From this triangle, if I say angle DAB, then here it will be angle
CBA, ma'am.
CBA. Very good. CBA. Because DAB, third vertex, first and then 3, 2, D is 3, A is 1, B is 2, 3, 1, 2. So here also 3, 1, 2, CBA, that's all. Okay, So here what we have to prove, ABD is equal to BAC. See here, ABD as it is, ABD is or BAC, CPCT. CPCT. The two triangles are congruent, so their corresponding sides and angles are equal. Got it, children?
Yes, ma'am.
Yeah. Yeah, this, like I forgot. I just started to explain. I wanted to ask you actually. So this, I'll not make that mistake. Go through the proof. I'll ask you questions. Write down. Give you 5 minutes. Read what's given. Go through the proof. Write it out in your notebook. And I'll ask you questions.
Completed writing, ma'am.
Yeah, Madhumita. What about others?
Completed, ma'am.
All right. What do we mean by equal perpendiculars? Equal perpendiculars. So
Ma'am,
look at
the
these.
measure of the lines are equal and they are perpendicular to each other, ma'am.
Perpendicular to AB, correct. They are
Yeah,
both, each of them is perpendicular to the line segment AB, correct. So that means, see, that's what I've written. AD and BC are equal perpendiculars to the line segment AB. That means AD is equal to BC because AD and BC, they are equal. AD and BC, they are equal. So that means AD is equal to BC and AD is perpendicular to AB. BC is also perpendicular to ABC. I've written them separately. The meaning of this is AD is equal to BC because they're equal. So AD is equal to BC. They're equal perpendiculars to AB. They're perpendiculars to AB. That means AD is perpendicular to AB and BC is also perpendicular to AB. So if AD is perpendicular to AB, AD is perpendicular to AB. That means they meet at right angles. This is 90 degrees. BC perpendicular to AB, BC, AB. That means they meet at right angles. This is BC, this is AB. They meet at right angles. Okay. And with this information, we need to prove that CD bisects AB. So what are we supposed to prove to show that CD bisects AB? CD bisects AB means CD cuts AB into two equal pieces.
ma'am, we should prove that AO is equal to BO, ma'am.
AO is equal to BO. CD bisects AB. That means CD cuts AB into two equal pieces. So you have to show that OA is equal to OB. OA is equal to OB. So clearly OA is of one triangle, OB is of the other triangle. So you just have, whenever you have to show that two sides or two angles are equal, it's all through congruency. Once you can see here that OA is a side of one triangle, OB is a side of the other triangle. So to show that OA is equal to OB, you have to show that the two triangles are congruent, and in CPCT you will get this result. So here they have not asked you to prove that the triangles are congruent. Then why are we proving? Because we know that OA is a side of this triangle, OB is a side of this triangle. In order to show that OA is equal to OB, we have to show that these two triangles are congruent. Once you show that they are congruent, that is, they are identical triangles, their corresponding sides will be equal. So through that you will get OA. OA is equal to OB. Through that you will get OA is equal to OB. So here they have not asked you to show that these two triangles are congruent to each other, but we have to do that. In order to get this result, OA is equal to OB through CPCT. Yeah, so it's vertically opposite angles. Then these angles, I've marked it here. Use this figure, children. I've marked here. See, angle 1 is equal to angle 2. Vertically opposite angles. Angle 3 is equal to angle 4, 90 given. And then it's given equal perpendiculars. AD is equal to BC. AD is equal to BC. So clearly, so class, which is the side included between the angles 1 and 3? Between 1 and 3, which is the side included between 1 and 3?
OM.
OA. Which is the side included between 2 and 4?
BO.
OBM.
Yeah,
OB.
BO or OB. Yeah, BO or OB. But have you mentioned OA is equal to OB here? No, something else we have written. AD is equal to BC. We have mentioned these two angles, but this is not the included side. we have mentioned these two angles, but this is not the included side. It's not the included side. So AAS, we have mentioned two angles. We have mentioned two pairs of equal angles and some other side. So AAS. In this triangle, we have mentioned about angle 1 and angle. We have written information about 1 and 3 in this triangle. This angle and this angle. Then the included side is OA. But no, we have written AD here. What we have written is correct. And in the other triangle, we have mentioned about 2 and 4. About 2 and 4. Then the included side is OB. But no, we have not said OB here. It's BC. AD is equal to BC. So clearly, the sides are not the included sides. Two angles and some other side. AAS rule, the triangles are congruent. And again, how to name it? If you say OAC, norm, okay, here the order is not given, so we have to name it. See, if you say OAD, 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 O is what? Angle 1. And you know it's equal to angle 2. So you should say O for the second triangle also. And A is angle 3. A is angle 3. So here it should be angle 4. So B. Then the third vertex C. If you say OAD, it is OBC. AAS rule. And once you name it correctly, you can see here OA is equal to OB, CPCTC. OA is equal to OB, CPCT, or AO is equal to BO. So if AO is equal to BO, that means CD by 6 AB. Yes, class, do we understand the difference between ASA rule and AAS?
Yes, ma'am.
Madhumita, you asked me the other day.
Yes, ma'am. Now I understand, ma'am.
Class, I'll tell you, because see, now in the beginning, when you ask me doubts, it's easy for me to answer. Once we finish NCRT and we're doing extra proofs, and then you ask me what's the difference between ASA and AS, you know, the mindset is different at that point. So it becomes difficult to explain for me. Please ask me now.
No, ma'am, it's clear, ma'am.
Ma'am,
Yeah, yes.
ma'am, can we use RHS criteria here, ma'am?
Okay, we'll see. You tell me. It's a good question. So Tanishka has this question because there's a right angle. So maybe she feels if there's a right angle, we have to use the RHS rule. Maybe. Okay, so let's see if we can use the RHS rule. Yes, Tanishka, tell me what you have in your mind. Yeah, start. Tell me.
Ma'am, angle A is equal to angle B because it's 90 degree, ma'am.
Okay, I have marked it 3 and 4. So please use 3 and 4. So angle 3 of the first triangle is equal to angle 4 of the second triangle, 90 degrees. Correct. This is R. Now you have to tell me H and S. Which is the hypotenuse? In the first triangle, which is the hypotenuse?
OC, ma'am.
In the first triangle, where there is angle 3.
OD, ma'am.
OD is hypotenuse. So you must have this information. OD is equal to, which is the hypotenuse in the second triangle?
OC, ma'am.
OC. Do you have this information? OD is equal to OC? It should be given.
Yes.
See, 1 minute. Just because we want to use the RHS rule, we cannot write OD is equal to OC. You should give a reason for that. What can be the reason? The reason can be given, meaning that information is given in the question. That can be a reason. Or if you write OD is equal to OC and that information is not given in the question, then you should justify. Like you should say something, for this reason, the sides are equal. You must justify. We cannot write an equality without a reason. If you write an equality, this angle is equal to this angle or this side is equal to this side, you must give a reason for that. The reason can be given. If it is given, you don't have to give a reason because it's given to you, so you're taking it. If it is not given, you must justify why you're writing OD is equal to OC. Now it's not given. So you justify why you're writing OD is equal to OC. Tanishka.
Yes, ma'am.
So we can't write. No way we can, meaning we don't have a reason to say that OD is equal to OC. It's not given. If it is not given, then you should give some reason. Why are you saying OD is equal to OC, Tanishka?
Ma'am, because AB bisects CD, ma'am.
AB? No, AB does not bisect. Does AB bisect CD?
No, ma'am, it is perpendicular.
No, they don't bisect at all. It's not given. Nothing is given about bisecting. It's neither given that O is the midpoint of CD, nor is it given that O is the midpoint of AB. It's not given that AB and CD, they bisect each other. That's not given. It's only given that this side is equal to this side. OA is equal to OB is also not given. Then OD is equal to OC is also not given. It's not given that AB bisects CD or CD bisects AD is not given. So then what's your reason? Why do you say that OD is equal to OC?
Ma'am, because O is the midpoint, ma'am.
O is the midpoint of CD, is it?
Yes, ma'am.
Where is it given?
It is not given, ma'am.
So you cannot write that. If it is not given, then you should, if you write it, you should give a reason for that. And we don't have a reason. We don't have a reason for that. That means you cannot write it. That means you cannot show that the hypotenuse is equal, which means you cannot use the RHS rule. You can use the RHS rule. You can use the RHS rule only when you can show in the two right triangles. When they're right triangles, you have a 90-degree there. Then the hypotenuse of both the triangles must be equal. And some other side of one triangle should be equal to another side of the second triangle. Only if you have this. Only if you have this information, you can use RHS. So H we don't have. H we don't have, but S we have, side we have. We have AD of the first triangle is equal to BC of the second triangle. AD of the first triangle is equal to BC of the second triangle, side. S we have, because this is given to us. AD of the any side. So AD of the first triangle is equal to BC of the second triangle. That is given to us. So we have R and S. We don't have H. We can write OD is equal to OC. But what's the reason? You should give a reason. We cannot write something without a reason. So since this information is not given, nor can we prove it is true, we cannot use the RHS rule. And it is not, if the two triangles are right triangle, it is not that we must use the RHS rule. We can use the SSS rule, we can use SAS, we can use AAS, you can use anything. It's not that if both are right triangles, you must use RHS. No. Not like that. You should have information that suits this congruence criterion. Is it okay, Tanishka?
Yes, ma'am. Understood.
Okay. Yeah. All right, children. So both are right triangles. We tried to use the RHS rule. We were able to write for R and S, but for H we were not able to write because the hypotenuse of the two triangles are not equal. They are not given to be equal, nor do we have any reason to say that they are equal. So we are not able to use the RHS rule. And here we prove using the AAS congruence rule. Yes, children, please write down this. Do not blindly write. I've done it in two ways. And I've shown the triangle separately. From the main figure, I've taken the triangle separately and shown it. and I've marked whatever is equal, I've marked. Please go through carefully and write down. There's no hurry. I'll give you 10 minutes for this. I'm right here. As you're writing, if you have any doubt, please ask me. Yeah, start.
Completed, ma'am.
Children, I was away. Was anybody trying to communicate with me? Okay, so I think no. Yeah. Done, children?
Yes, ma'am. Completed.
Almost done.
Yes,
ma'am.
ma'am. Completed, ma'am.
All right, yeah. All of you?
Completed, ma'am.
All right. So children, I think we are running out of time. We don't have time to discuss this. So here we can apply the properties of a parallelogram. In a parallelogram, I'll just tell you about that. So in a parallelogram, opposite sides are equal. And from the name, why is it called a parallelogram? Because it's a quadrilateral in which both the pairs of opposite sides are parallel. Parallelogram is a quadrilateral, is a four-sided figure, is a four-sided polygon in which both the pairs of opposite sides are parallel. That's why parallelogram. So when you have parallel lines, you find alternate interior angles. So you can use them. So that information may not be given, but you can get all that because you have parallel lines. Parallel lines. So you can get alternate angles. And also when you prove it's a parallelogram, opposite sides are equal. When you prove it's a parallelogram, how do you show that a quadrilateral is a parallelogram? When both the pairs of opposite sides it's parallel, it's a parallelogram. When both the pairs of opposite sides is parallel, then it's a parallelogram. Once you say it's a parallelogram, opposite sides are equal, opposite angles are equal, opposite angles of a parallelogram are equal. Then because of the parallel lines, you can find alternate interior angles equal. So using all this, you can show that the two triangles are congruent to each other. So we'll see this step by step in the next class, children. Just take a PPT of this one. Please finish this. Quickly take a screenshot. Please take a screenshot of this one. Finish this by the next class.
Taken.
Taken, ma'am.
Yeah, this one.
Taken, ma'am.
Taken, ma'am.
Okay. This one.
Taken, ma'am.
Done, children?
Yes, ma'am.
Okay. Yeah, this one.
Ma'am, can you please show it for a second?
Sure,
The
sure.
seventh one.
Yeah. Sure.
Taken, ma'am.
Yeah.
Taken, ma'am.
Yeah. That's it.
On the eighth
Yes.
one.
Yeah.
Taken, ma'am.
Yeah. Please finish all this before you join the next class. So next class we'll discuss all these proofs. And we'll also be doing some extra proofs. Before moving on to the next exercise, we may do extra proofs, or I might also start the next chapter, because doing proofs continuously sometimes is boring for children. So I might also start off a numerical chapter like Heron's formula. So maybe some 45 minutes we'll do this, and then we can switch to a different topic just to make it more engaging. So I might do that also. I don't know. Finish all this by the next class, children. All right. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank
Thank
you.
you, ma'am.
Thank you.